Okay, so we're going to have a look at compound measures. You've got three: speed, distance, time, mass, density, volume, and force, area, and pressure. Speed, distance, time should be very familiar to you. I remember the mass, density, volume as my DVD. And then this one is FAP, FAP. So look at the first one. Travelling time, so it's 1 hour, 15 minutes. Just make sure your units are consistent. That's 15 out of 60 of an hour, or 1¼ hours, or 1.25 hours. Do not put this into your calculator as 1.15 because that would be incorrect. The speed is 56 kilometers an hour. You want the distance. Distance is the speed multiplied by the time. Now, another way of doing the time is to keep it in minute form. So I'll show you how you do that. You can put it into your calculator as 1 and 15 over 60. That will work as well. Just using your fraction button. So on your calculator, you put in 56 times. Now if I put it in as a fraction, you press shift and then your fraction button here, and you write it in as a fraction. So 1/15 over 60. Giving you an answer of 70 kilometers per hour. Number 2. Jim was caught speeding by a pair of average speed cameras. The speed limit was 50 miles per hour. So I'll write that down. Speed 50 miles per hour. Always check your units in these questions. The cameras were that apart, and that's in meters. So first of all, I might change that into miles. So I have got 2.5 kilometers. Now, 1 mile, as I often say in the class, is 4 laps of a track, 4 by 400s. So 1 mile is 1.6 kilometers. So that means that 1 kilometer, you divide by 1.16, is 1 divided by 1.16 of a mile. You've got 2.5 kilometers, so times this by 2.5. So it's 2.5 divided by 1.6 of a mile. So that works out to give you 1.5625 miles. So your distance is 1.5625 miles. The time taken to pass between the cameras is now, this is in seconds. So to change it into minutes, you divide by 60. To change it into hours, you divide it by 60 again. And that will give you 17 over 600 of an hour. What was Jim's speed before between the cameras? So his speed is distance over time. So his distance is 1.5625. His time is 17 over 600. Again, use your fraction button in there, and that will give you a speed of 55 miles per hour. Now part B says, if Jim was travelling at the speed limit, so it's part A, so part B, so his speed was 50 miles per hour. So we didn't need this over in this section. The distance is the same, and the distance worked out to be 1.5625 miles. What is the minimum time? So time is distance over speed. So working that out, his distance over his speed of 50, and that's coming up at 1.8. That's coming out as 1/32 of an hour. To put that into minutes, times it by 60. To put it into seconds, times it by 60 again. So his speed is 113 seconds. The next one, example 3. In 2019, Mo ran a long distance race. His distance was D. And he finished it in time, T. So his first speed was distance over time. In 2020, he ran the same race, but it was faster. So his second speed was the same distance, but it was 10% quicker. So that meant he did it in 90% of the time. So his time is 90% of what it was before. So 90% is 0.9. Now the two distances have remained the same. So speed 1 times time equals distance, just bringing that t over. 0.9 t times speed 2, just bringing it over to our side, equals distance. Them two are equal. So speed 1 time equals 0.9 time speed 2. Those cancel off. So speed 1 is 0.9 speed 2. So speed 2, just bring that across, is 1 divided by 0.9 speed 1. So speed 2 is 1.111 speed 1. And you want the percentage he has increased by. So his original speed was speed 1. So you want the percentage change, which is the change over the original times 100. Now his original speed was speed 1. His new speed is 1.999 times speed 1. So the change is, if you take, I'll write this down here. So speed 1 is what it was. It is now 1.111 speed 1. So the change, 1.11 take away 1, basically, is 0.111. So that's the change, 0.111. Original speed was just 1s, so I just put the speed in there, times 100. S is cancelled off, leaving you with 11.11%. And that's that's a very tricky question, to be fair. The next one down here, the mass of a statue is 360. The density, and again I'm just checking my units match, and they do. The density is 1800. Calculate the volume. So mass, density, volume. Volume is mass over density. So it's 360 over 1800, which is 0.2. And the units are metre cubed. Part B. It's decided the metal has been changed to one with a different density. Its mass is now 220. So we are assuming that the volume has remained the same. So the volume is 0.2. Calculate the new density. Density is mass over volume. So 220 over 0.2 gives you an answer of 1100 kilograms per metre cubed. I have more questions to do in this because it's quite a long section here. Example 5. An iron cube has side of 4. So I'm picturing that. 4, 4, 4. So that means its volume, because we're dealing with density, so it's all mass, density, volume. So its volume is going to be 4 cubed, which is 64. Its density, and you're taking the units, that's centimetres cubed. Its density is 7.4 grams per centimetre cubed. What is the mass? So mass, when you read triangle again, so mass, density, volume is density times volume. So it's 7.9. 7.9 times 64, 505.6, and we're in grams. That's part A. Part B. A larger iron cube has mass 63.2 kilograms. What is the ratio of the lengths of the sides? So let's work this out. It's the same metal. We're assuming it's the same metal. So the density is 7.9. So the volume is mass divided by density, 63.2 divided by 7.9, to give me 800 centimetres cubed. This is a bigger cube. We know the volume, so to work out each of its sides, x cubed equals 8,000. So x equals the cube root of 8,000. So x is 20. And I want the ratio of the small side to the large side. So the small side was 4, the large side was 20, and that cancels down 1 to 5. Now, next one I'm going to look at is a very tricky one. Brass is a metallic alloy. One type is 70% copper and 30% zinc. Copper's density, you're not told the volume. So just pick a nominal value. So let's say the volume is 10 centimetres cubed. So that means then that the copper would have a volume of 7 centimetres cubed, and the copper density is 8.9 grams per centimetre cubed, and the zinc would have a volume of 3 centimetres cubed. If you took your volume, I should write that as 10 centimetres cubed. If you kept your volume as 10, this one's 7 and this one's 3. If it was 100, this one would be 70 and this one would be 30. It will still work out in the same, as long as you have got 70% is for copper and 30% is for zinc. The density of the zinc is 7.1. Now, I need to work out the mass of each of these. So mass is density times volume, so timesing them up. The mass of that is 62.3. The mass of this one is density times volume, 3 times 7.1 to give me 21.3 grams. So my total mass is those two added together, 62.3 plus 21.3. Adding them together, 83.6. And the question wants the density. So density is your mass divided by your volume. So 83.6 divided by your volume, and it gives you 8.36 grams per centimetre cubed. You start running through that again. You have to pick the volume. So I picked it 10. So that meant that was 7, that was 3. If I picked the volume to be 100, that would be 70, and that would be 30. And just down at the end, I divide by 100. It will still work out exactly the same way. Now, example 7. This is new onto the course and hasn't been examined very many times, but we have to have a look at it. Cuboid's 3 different faces, 20, 40 and 3 metres. First thing I would change that into 300 centimetres. Calculate the pressure. So pressure, that's the FAP, FAP. Pressure is force over area. So calculate the pressure in the cuboid when it exerts, when it is resting on force, when it is resting on face A. I can't even remember writing here. So I should have put in here the weight of this cuboid. So the weight of that cuboid is 40 newtons. So the force is 40. The area, if you're looking at face A, the area of face A is 40 times 20. Now that's in centimetres. So let me just check. It's wanting it in metres squared. So I'm going to have to change these into metres now. You're always constantly checking your units in these. That's me in metres now. So it's 40 over 0.08. So newtons over metres squared to give you an answer of 500 newtons per metre squared. That was part A. Part B. 3 of these cubes are stacked on top of each other and the bottom cuboid is resting in face B. So it's resting on the base. So the area of that is 40 times 300 and that's in centimetres. They want it in metres squared, so let's put it back into metres. So that is 1.2 metres squared. Now, the pressure is the force over the area. You have got 3 of these. So the force is going to be 3 times. Each one's 40, so 3 of them. Times it by 40, divided by the area. Units all match up nicely here. And that gives me an answer of 100 newtons per metre squared. Now I have one more of these questions to do, and that is us finish this topic. So it's quite a tricky one as well. A cone has got base diameter of 20 centimetres, so centimetres. I'm noticing there it should be into metres, so let's put it into metres straight off. The base rests on horizontal ground and it has a pressure. So pressure is 650 newtons per metre squared. So let's write out a wee triangle, FAP. So I need the area. Area of the base is a circle, pi r squared. Now, pi, your radius, your diameter is 0.2, so your radius is going to be 0.1 squared. And if you work that out, it's 0.0314159 metres squared. So, but no, we want the weight, so that's the force. So the force is the area times the pressure. So 0.0314159, the pressure 650, multiplying those two together, 20.42 newtons. So for us, the force is the same as the weight. Part B, the diameter is now halved. So we've got a different situation going on here. So the diameter is now 0.1 metres. Okay. What effect does this have on the pressure? So pressure is going to be different. The area is going to be different. Pi r squared. Pi, your radius is half that. So 0.05 squared, which is 0.00785,398. Now the weight of it stayed the same. So it's 20.42. And I want the pressure. Pressure is force over weight. And just check your units all match up. Now that was done in metres, so that's meters squared. Meters squared. I'm putting those two in. So the pressure is now 2600 newtons per metre squared. The question said, what effect does this have on the pressure? So let's look at this. The pressure was, from the beginning, 650. And the pressure is now 2600, which is basically, let's see how many times bigger it's got. So 2600 divided by 650 gives me roughly 4 times the pressure. Now again, that's a very difficult question to say pressure is new onto the course. So I would look carefully at these questions.